Okay, so this is some information on how to store things in your database more securely, or rather put a guide on where to put it and how to stick it there safely. So, as you saw on PHP MyAdmin, you'll probably end up with a table that looks something like this. You'd have your users, email, and then you have to have some way of verifying your user. So you are going to have some kind of a password thing. And the question is, how do we securely store them there? What goes there? Well, plain text is not our best option here. If a hacker gets into your database and sees this table, he can pretty much just go to whatever the login page, type in Mark, go Broncos, 69, and he will be in. Also, this is not the right PowerPoint. Or it doesn't have the animations, which is going to cause a lot of problems later. But we'll get to that. We'll cross that bridge when we get there. So what? Our database is secure. Well, that's what you think. No matter how secure your database is, you always want fail-safes. You definitely don't want to store passwords as plain text. You definitely want to do it the right way. Just some examples: Microsoft, Living Social, Snapchat, Sony. It never hurts to be too secure. Oh, animations do work. Snapchat, I think, as far as I know, they just linked credentials, right? There's nothing that important, maybe email addresses, but phone numbers.
Had a public API.
There's like 4 million?
Yeah.
4 million users.
That's why you shouldn't use Snapchat. But then, just in the last 2 years, I mean, plain text, passwords, that's pretty bad. And Yahoo, Domino's. So what's the solution? Salted hashes. And we have to start at what's a hash. So a hash is basically taking, man, this slideshow looks, it's all messed up. It looked way better on my computer. I don't think this, I don't have a VGA thing. Or an adapter. Yeah. So it's a hash. It takes something, a string, in our case, like secret password, and it does some sort of encrypting algorithm. This one would be SHA-256, which is pretty standard. And it sends it to basically, it's a one-way, it's an encryption to basically gibberish as far as anyone reading it's concerned. Also, a dish of cooked meat, cut into small pieces and cooked again, most often with potatoes. But what about the salt? Well, salt is random data that you throw onto your password before you hash it. But why would we do this? Well, basically things hashed without a salt can be dehashed. They're pre-calculated tables or lookup tables, and they're corresponding plain text. They make finding a password given only its hash trivial in many cases. How big are these lookup tables? Does anyone have a guess of like how many entries or how many gigs are in like?
Terabytes. It's the largest one I've seen.
That's the largest one you've seen? Well, just the first. Is that more than one? Or is that just one table? Because the biggest one, all the
LAM hashes and MD5 and SHA-120.
Wow, just like an archive of all of them that could. Well, the first link I clicked on, I think it was like crack. I'm pretty sure it was called crack something that sounded like it was a crack house or like an online crack service. But we'll see it in a second here. But they say that their database is just the first link I clicked on when I typed like dehasher or like reverse lookup or something like that. So every word from all the Wikipedia databases, and they added every password list they could find. And when they're done, it turned out to be 190 gigs of MD5 and SHA-1 with 15 billion entries. And for other types of hashes, almost 20 gigs. So that's quite a lot to at their disposal. All right, this is where the animations may cause a problem. But anyway, so there are things called rainbow tables that basically they can piece words together and try to reconstruct what the password was based on its hash. And this is just an online one, and you can see it working there. Oh yeah, oh that looks so nice.
Google's also a very good way of doing hashes as well.
Really?
Just copy and paste the hash.
Just paste the hash in?
And sometimes you just get a result.
That's just because they're trying to do everything now. Google. Oh, okay, well, if you look with a microscope, you could see that this hash right here that you can't see is the same thing there. So, yeah, you can just look it up. Are we doomed? Well, not quite. This only works for unsalted hashes, and that's where our salt comes in. So a salt is just a randomly generated string, or in our case a string, and what you basically do is before you hash your password, you throw the salt on, and then you run it through the hashing algorithm. And then what you end up with is this encrypted string of, it's basically, you can't go back from it because it's the password mixed in with the salt. So you can't separate them. You can't like go backwards and then separate them. Or it's not that easy. There are ways to do it with brute force. Yeah, you can do it through brute force, but it's no longer as trivial. But even a better solution to that is using something called bcrypt, which is based on the well-known and easy-to-understand blowfish block cipher algorithm. The advantage that bcrypt has over traditional hash and salt methods is it has something called a key factor, which slows down the hashing process. But can anyone think of why you'd want to slow down the speed of your own hashing algorithm besides Richard? Okay, Richard.
Because if someone's trying to do a brute force, then they're going to be wasting a lot
Right.
of AWS.
Exactly. So, SHA-256 hashes can be done in about a microsecond. Bcrypt with a key factor of 12 takes about 0.3 seconds. So using math, a brute force attack would take about 300,000 times longer against code hashed using bcrypt than one hashed with just regular SHA-256. So are we secure? Well, not quite. There's still SQL injections that we have to worry about. What is an a SQL injection? I don't know why I say SQL. Because it's right in my face, SQL. Well, users can potentially pass harmful code into our server through input fields in the HTML or even in the URL. The problem is most easily explained by example. So if you have data you expect, like username, and you're just expecting them to type in something like, I don't know, their name or something not malicious, and then you have your query select from users where ID equals expected data, what that's going to do is run a select, as you can see at the bottom, on your table. And but the problem is if they type in something that you're not expecting, it's represented by spoiled data, it will throw that drop table with users on after the like intended query is processed. So we have to stop that from happening. And okay, hold on. Oh, wait. Oh yeah, animations. Yeah. So the solution can be found in prepared statements. Instead of sending the entire query to the program at once, we first send the program to the server with placeholder variables, which looks something like this, courtesy of Kevin Hicks sending me this code. So the first thing we do is, these are placeholders, these are like uninitialized values that we're going to send to our server. And what this does is it separates the way that we send information to our table. So first they get these, and then after they already have the placeholders, we fill them separately, making them not part of the executable program by the bind parameter. And why does this work? This works because we send the program to the server first without the potentially harmful user input. Then when we bind the parameters and call execute, we send the user input in a completely separate query, nullifying any harmful effects the user's input could have had. And that is how you secure your database. Any questions? Okay.
Are there issues with using prepared statements?
There are, but I think it's good in most cases. You could still sanitize your input, I think, before you send it. But from what I read, it's pretty good, right? It's pretty...
Or what are the other advantages to it?
To prepared statements?
I've heard
variable can change, and then you can execute it.
Oh, it's more efficient, right? If you're accessing your table over and over again, yeah. So yeah, you can just, so you change what? You change the placeholder data and just resend it, right? Yeah. So it's also more efficient. Okay. Cool. Anything else? Okay, well that's it then.